Hello students, I've gone through the response of assignment number 1. So first of all, let me tell you that the total responses against the 66 students who have enrolled for the class, only 12 students have submitted the assignment. So this number is not good, not inspiring. So I request you all to please complete your assignment and these assignment will be graded. Then, when I see the questions which are raised in the assignment, I find some common doubt in the circuit, understanding of circuit. So, in this one or two slides, I will try to cover a very basic understanding of circuit elements and specific doubt of the students I'll be covering later. So, if we see how a DC-DC converter is designed, there are certain very basic elements which have been used and they are used in almost all the circuits. They are connected in one way or another, right? So there is a DC voltage source which is input, then there is a resistor in a circuit which we have taken as load at times. So we understand resistor very well. We understand that resistor is a linear element, and if we increase voltage across it, the current will increase because it follows a linear relationship. So our understanding of resistor is very clear. Then we find a capacitor also in a circuit, which is in all the circuits connected in parallel with the load. The reason of using a large value of capacitor is to control the output ripple. Why? Because DC to DC converter is basically designed to have a DC output from the circuit, right? So output ripple has to be as less as possible. Then there's a diode. The purpose of diode in the circuit is number one, to provide a path for inductor current to flow. In case there's no other path for inductor current to flow, a diode is connected in parallel with the inductor and it will provide a path which we also called as freewheeling diode for the inductor. Or in some of the circuits, the diode is used in such a way that it prohibits the direct flow of current in a particular direction. We don't want the current to flow back to the source, or we want to disconnect the source and the load. So in that case we use diode in the circuit. So our understanding of diode is that it is a unidirectional device and current will flow through the diode only when it is forward biased. Then there is inductor in the circuit. So basically inductor and capacitor are used to store energy in the circuit, and we have in almost all the derivations you will find that I have used the same procedure. The procedure is entirely same. So what we need to understand is what is the basis of that procedure. So let us take up inductor and capacitor and understand how they work. Okay. I have one more request here, that please do not go through the lectures randomly. Follow the order in which the lectures have been uploaded, because one lecture is closely related to another. So if you just pick any lecture and start listening to it, you might not follow each and every point which is being specified there, which is being discussed in the lecture. So kindly make note of this also. Let us start with the understanding of inductor. So basically inductor acts as an energy storage device in DC to DC choppers. It stores energy in a electromagnetic form. So we need to know what happens if the periodic current and voltage is there across the inductor. What does that mean? For periodic current and voltage, what that means is that for any time period capital T, okay, so if we take a value of certain time period, the value of current at any instant plus the time period will be equal to IT, and similarly the voltage. So you clearly know that it is a repetitive voltage or current waveform. So if we pick up any time period and analyze the circuit for that time period, that particular analysis is applicable for all time periods, right? Secondly, if there is a inductor stores energy, how do we write it? It can be written as half Li square, where L is the value of inductor and I is the current flowing through it. This is a very basic relationship for the energy stored in inductor. Now, if the current is periodic across the inductor, the stored energy at the end of one time period is same as at the beginning, okay, because there is no net transfer of energy, and this is what we call as steady state. At this time period the average power absorbed by the inductor is zero, so whatever energy it is storing, it will give that energy. So the average value or the net energy transfer will be zero. This is what we call as steady state. So when we specify that we are analyzing a particular circuit in steady state, keep this into mind. So what happens if we take this into consideration is, let us see what is the voltage current relationship in inductor. Okay, so V is equals to L di upon dt, which can be written as V into dt is equals to L into dt. So we can integrate it over a time period, and let us say I am integrating it for a time period 0 to t, and if I open the right hand side for the current, it will be L into the value of current at instant t माइनस द वैल्यू ऑफ करंट एट इंस्टेंस ज़ीरो, मतलब जहाँ से वो टाइम पीरियड स्टार्ट हो रहा है और जहाँ ख़त्म हो रहा है, उन दोनों टाइम पे जो करंट की वैल्यू है उनका डिफरेंस. तो अगर हम वेव फॉर्म देखें इंडक्टर की, द इंडक्टर करंट इज स्टार्टिंग value at 0 time period is same as that at t, isn't it? These two values are same. See the waveform, it is a periodic waveform across the inductor, and we have applied a signal which is on for certain time, which is off for certain time. So when it is on, it is charging the inductor. When it is off, the inductor is giving away the energy. So the net transfer of energy is zero. So that we can also say that at the end of the time period, we can see here in the waveform that the value of current at 0 and the value of current at t are exactly same. So this can be written as 0. So this means the average value of voltage across the inductor for one time period, it is also 0. From this relationship I can conclude that because 0 to 2 t vt, instantaneous value of voltage for integrating one time period, is nothing but the average value of the voltage. This is also 0. So this we can observe in the waveform also. Wherever we have drawn the voltage waveform for inductor, we have seen that this relationship is this, that the average value is 0. You can see here the Voltage for one time period is positive, for another time period it is negative. So it is 0. Further, this can be written as average voltage into dt. Okay, it can be written as the value of voltage for t on time into t on time, the duration of time, plus the value of voltage for t of time into the off time is equals to 0. This is popularly known as volt time balance in inductor. So whenever we discuss inductor circuit, there's a concept of volt time balance in inductors, and this is how it has been interpreted. Right now, this is the what we have concluded, that average value or the difference of the current at instance t and at instance 0 is ultimately 0 because it has the same value. So we can also write this condition, the steady state condition, as the overall change in the current when the waveform is on, during the on time of a waveform, plus the overall change in the current when the switch is off. It should be 0, isn't it? You can see from the waveform also that delta IL closed is equal to delta IL open for every inductor circuit which is in steady state. This condition is also true. So this is another way of analyzing the equation for the steady state. So you will find several videos. In those videos, they would have used voltage time balance to analyze DC to DC choppers. What they are doing is they will find out the value of voltage across the inductor during on time, the voltage across inductor during off time, and putting that in a voltage time balance equation, we substitute or we calculate the relationship between output and input voltage. It is simple as that. In the analysis which I have presented in the videos, I have used this concept. For the steady state, the net change in inductor current during the time for which it is connected across the supply voltage and time during which it is not connected across the supply voltage will be 0. So this expression has been used to analyze a circuit. This is what the steady state means in case of inductor. I'm once again discussing the difference between the continuous current mode and discontinuous current mode. In the previous lecture also, I have used this figure to make out what the difference is. Now, there's a confusion that why this current I minima is starting from this point. How it is possible? Why it is not starting from 0? The reason behind this is that we have assumed that the circuit is at steady state. So this starting from 0 will happen at the first instance, that is at the point when we just switch on the circuit. It will definitely start from 0. But once the circuit comes into the steady state, it will rise from a minimum value to some maximum value and fall back to some minimum value, and this behavior will continue for the periodic input signal. So you can just assume that we have taken a chunk of a waveform which is continuous, and we are analyzing the circuit for that portion only, and this portion we have defined as t, because we know that this behavior is repeating every t seconds, which is the time period for the waveform. Second thing is that in a continuous current mode, we put the condition that current in the inductor will never fall to 0, which means that it will never go back to its initial state, which is the state when we have just switch on the circuit, only that time the current through inductor was 0. So we don't want the circuit to start from that initial position again. So we call it as a continuous current mode because there is always a current flowing through a inductor, and it never, this value of current never falls to 0 value. If it happens, if it falls to 0 and for some period of time it will remain at 0, in that case it will always start from a 0 position, then rise, then in again next time period it will start from 0 position and then rise. You just remember that when the circuit is starting from a 0 initial condition, when there is no energy stored in inductor, at that time is a transient time, it is not a steady state time, right? So in the second case the situation is entirely different. We are always initializing the inductor from its 0 value and then applying the conditions. So in a steady state we have to assume, we have to take this condition into mind that the current in inductor is starting from some minimum value, and this minimum value is equal to a next minima again, and the maximum value is equal to next maxima again, and so on. So it makes our derivation very simple, and it is easier to understand a circuit, analyze the circuit under this condition. So in electrical engineering, we although study a circuit in discontinuous current mode also. Second thing, so we put a boundary here. The boundary condition is when we call that it is a difference between a continuous and discontinuous current mode, that is a point when I minima just touches 0. So that is why we have put this condition I minima is equals to 0. We have used this condition in the discussion for a boundary where it shifts from a continuous to a discontinuous current mode. Okay. So another basic component for design is a capacitor. Capacitor is a dual of inductor. It is again an energy storage device, and it stores energy in a electrostatic form. So basically, so we can say that the energy stored in capacitor is half CV square, and if the capacitor voltage is periodic, the stored energy is same as the end as that at the end of the period and at the beginning. It is same at the end and the beginning. So average power which is absorbed by the capacitor in steady state is 0, right? So we can prove this by using a voltage current relationship for the capacitor, and it says that I is equals to C dV upon dt. We can just integrate it to find the average value of current, and it comes out to be the value of C into the voltage at the completion of time period minus the voltage at the beginning of time period. Now because there is the stored energy is same at the end at the beginning, so this parameter will be 0. So we can say that the average current stored in the capacitor or average current input to the capacitor is 0, right? So we can also write this as the value of capacitor current for on time multiplied by the duration of on time plus the value of current for the off time multiplied by the duration of off time will be 0. This is popularly known as current time balance in a capacitor. And you can just see here that we have used a capacitor current waveform such that the average value of capacitor current is 0. This is because we have assumed that capacitor is in a steady state. So the average value of capacitor current is 0. This also means that the charge stored in capacitor during off time and the charge stored in capacitor during on time will be same. And this is why we have used this expression to calculate the value of capacitor in the derivations. So you just remember the current time balance in the case of capacitor and voltage time balance in case of inductor, and this is the basis of this why we have used IC average is equals to 0 in all the waveforms. So for the basic understanding what we have discussed till date, the content has been taken from this book, Power Electronics, from Daniel W. Hart. And basically, inductor and capacitors discussed in this unit are given in chapter 2. We have taken the content for buck converter, boost converter, buck boost converter, which is chapter 6 of this book. The numericals are very good and it presents the clear understanding. Then there was a question from a student that the buck boost converter is not mentioned in the syllabus, and do we have to do the study it in detail? Is it required? The understanding of buck boost converter is very important because the next unit, which is the DC power supplies and chapter 7, it starts from buck boost converter only. So if we want to study that chapter, buck boost converter is an important circuit, and examiner can assume that you already know it. So whether or not it is specified in the syllabus, we have to go through it. So for your understanding, I will be uploading this book, PDF of this book, and you can just download it and go through it. Thank you.